Ever ponder why the solid ground beneath us suddenly starts shaking? This is the intriguing world of earthquakes, a natural phenomenon that has shaped our planet and our civilizations for millennia. But what exactly are earthquakes? How do they come to be? Well, it's all about the unseen force that's constantly at work underneath our feet. You see, the Earth's crust, the outermost shell of our planet, isn't a single solid piece. Instead, it's like a giant jigsaw puzzle, made up of several large pieces known as tectonic plates. These plates are always on the move, sliding past each other, colliding, pulling apart. This movement, although slow and often imperceptible, is a constant and powerful force that shapes our world. Now you might be wondering how these tectonic plates move. Well, they're not just floating aimlessly. They're driven by the heat deep within the Earth's core. This heat creates convection currents that rise up, pushing the tectonic plates along. It's like a pot of boiling soup. The heat source is at the bottom of the pot, and as the soup gets hot, it rises to the top, then cools and sinks back down, creating a continuous cycle. That's a simplified way of understanding how the tectonic plates move. But here's the catch. Although these plates are constantly moving, they're not always smooth in their motion. Sometimes they get stuck at their edges due to friction, but the forces that drive them don't stop. They keep pushing or pulling, causing stress to build up. And when the stress becomes too much, the plates suddenly slip, releasing a huge amount of energy. This energy travels through the Earth in the form of seismic waves, causing the ground to shake. And voila, an earthquake is born. So the ground beneath us is constantly moving, even if we can't feel it. It's the unseen force that drives the ever-changing face of our planet, and it's the force behind the powerful and sometimes destructive phenomenon we know as earthquakes. Imagine the Earth's crust as a giant jigsaw puzzle, with pieces constantly shifting. These pieces, known as tectonic plates, are not static. They are giant slabs of rock, some as big as continents, others the size of a small country, all floating on a semi-fluid layer of Earth's mantle. This is like a massive raft bobbing on the ocean, where the ocean is the mantle, and the raft is the crust. The tectonic plates are composed primarily of two types of crust: the denser, thinner oceanic crust, and the lighter, thicker continental crust. This composition plays a significant role in how these plates interact with each other. Now, these plates don't just float around in a leisurely fashion. They move, they interact, they collide. And it's this dynamic dance that shapes our world. There are three main types of plate boundaries where this interaction occurs: convergent, divergent, and transform. Convergent boundaries are where two plates move towards each other. When a denser oceanic plate meets a lighter continental plate, the oceanic plate is forced under the continental plate in a process called subduction. This can lead to the formation of deep ocean trenches and volcanic activity. Divergent boundaries are where two plates move away from each other. This happens primarily under the ocean, creating a gap where magma rises to form new crust. This is how the Mid-Atlantic Ridge was formed, a mountain range that runs down the center of the Atlantic Ocean. Lastly, transform boundaries are where two plates slide past each other. This grinding action doesn't happen smoothly and can cause the plates to get stuck. When the force becomes too great, the plates suddenly slip, releasing a huge amount of energy in the form of an earthquake. These moving puzzle pieces of the Earth are the root cause for earthquakes. They shape our land, build our mountains, form our oceans, and yes, they cause our earthquakes. It's a dynamic, ever-changing world beneath our feet, and understanding it is key to understanding why and how earthquakes happen. What happens when these giant puzzle pieces collide or slide past each other? Well, that's where the story of an earthquake begins. Just like the tensions between two old rivals, stress builds up when tectonic plates interact at their boundaries. This stress isn't something to be taken lightly. It's a colossal force, a silent beast waiting to be unleashed. But unlike most beasts, it doesn't pounce unexpectedly. It waits. It waits for the perfect moment when the plates can't take it anymore, when the stress becomes too much to bear. This is a story of pressure, stress, and release. It's a story that unfolds deep within the Earth, far from human eyes. Over millions of years, these tectonic plates, these giant puzzle pieces we spoke about, move. They shift, they grind, they collide, and they slide past each other. The stress at their boundaries accumulates, building up over time, much like a pot of water on the verge of boiling, and then, like a pot finally reaching its boiling point, the stress reaches a critical threshold. The plates can't hold it in any longer. The energy has to go somewhere, it needs an outlet, and so it breaks free. It ruptures the Earth's crust, a sudden release of energy in the form of seismic waves. These seismic waves are like ripples in a pond, radiating outwards from the point of release. They travel through the Earth, shaking and trembling as they go. They're the bearers of the energy that was once trapped, the energy that the plates could no longer contain. This isn't just a geological event, it's a spectacle of nature, a display of Earth's immense power. It's the birth of an earthquake. The ground beneath us shakes, buildings sway, and the world as we know it changes in an instant. All because two pieces of Earth's crust decided they couldn't take the pressure any longer. This sudden release of energy is what we experience as an earthquake. Ever wondered how this energy travels from deep within the Earth to the surface? Well, it's time to meet the messengers of chaos, the earthquake waves. They come in three main types, each with its own unique way of moving and causing shaking. First up, we've got the P waves, or primary waves. These are the speed demons of the earthquake world, racing ahead of all others. They move in a push-pull motion, just like the way sound travels through the air. This means they cause the ground to expand and contract, but the shaking is usually not strong enough to be felt by us. Next in line are the S waves, or secondary waves. These are a bit slower than P waves, but they make up for it with their destructive power. S waves move in an up and down motion, causing the ground to shake vertically. This is the shaking that you typically feel during an earthquake. Finally, we have the surface waves. These are the last to arrive, but they're the ones that pack the most punch. They move in a rolling motion, similar to ocean waves, causing the ground to move both up and down and side to side. This complex motion is what causes most of the damage during an earthquake. So, when an earthquake happens, it's like a relay race. The P waves start off, followed by the S waves, and finally handed off to the surface waves. Each wave type carries the energy from the earthquake's epicenter, spreading the message of chaos to the surface. These waves don't just shake things up for the sake of it, they carry vital information about the earthquake's location, size, and even what the Earth's interior looks like. Scientists can use this information to learn more about earthquakes and hopefully one day predict them more accurately. So the next time you feel the ground shake beneath your feet, remember, it's not just random chaos. It's a message, a story being told by the messengers of chaos themselves. These waves are the true culprits behind the shaking and damage we see during earthquakes. Why is it important to understand earthquakes? The power of an earthquake is undeniable. It can shake the very foundations of our world, causing destruction on a massive scale. Buildings topple, roads crumble, and lives can be irrevocably altered in a matter of moments. The aftermath of a potent quake can leave a cityscape unrecognizable, a jumble of debris where once stood a bustling metropolis. But the impact of an earthquake extends beyond the immediate devastation. The violent shaking can trigger landslides, turning once stable slopes into torrents of soil and rock. It can also cause the ground to liquefy, swallowing buildings and infrastructure whole. In coastal areas, the seismic activity can displace vast amounts of water, spawning tsunamis that crash onto shorelines, causing further destruction and loss of life. Yet, despite the chaos and devastation, there's a silver lining in our understanding of these seismic events. The more we understand about earthquakes, the better equipped we are to mitigate their effects. Earthquake preparedness is not just about knowing what to do when the ground starts shaking, it's about designing and building structures that can withstand the forces unleashed by an earthquake. It's about creating communities that are resilient, able to recover and rebuild in the aftermath. Our understanding of seismic activity informs building codes and construction practices, helping to create safer buildings and infrastructure. It guides the development of early warning systems, providing precious seconds for people to take cover or evacuate. It helps us identify areas at risk of landslides or liquefaction, allowing us to take preventive measures. In essence, our understanding of earthquakes empowers us. It equips us with the knowledge and tools to stand firm in the face of nature's power. It helps us transform our fear into action, our vulnerability into resilience. Understanding earthquakes is not just a matter of curiosity, but a matter of safety and resilience in the face of nature's